In the world of electronics, data flows like a river, carrying information between different parts of a system. Just as a river branches out into various streams and tributaries, data in a digital system needs to be directed to different paths to reach its intended destination. This flow of data is crucial for the functioning of any electronic device, from the simplest gadgets to the most complex supercomputers. Sometimes, we need to direct this flow, sending specific data to specific destinations. This is similar to how a postal system works, where letters and packages are sorted and sent to various addresses. In the digital world, this sorting and directing of data is often managed by specialized components within the system. These components ensure that the right information reaches the right place at the right time, maintaining the efficiency and reliability of the system. That's where demultiplexers come in. A demultiplexer, often abbreviated as demux, is a critical component in digital electronics. It takes a single input signal and distributes it to one of several output lines. This process is akin to a traffic cop at a busy intersection, directing cars to different roads based on their destinations. Without demultiplexers, managing the flow of data in complex systems would be incredibly challenging. Imagine a railway switchyard, guiding trains onto different tracks based on their destinations. Each train represents a piece of data, and the tracks represent the various pathways the data can take. The switchyard operator ensures that each train reaches its correct track, just as a demultiplexer ensures that data is sent to the correct output line. This analogy helps us understand the importance of demultiplexers in organizing and managing data flow. Similarly, a demultiplexer is a digital circuit that acts as a data distributor, taking a single input signal and channeling it to one of several possible output lines. This functionality is essential in various applications, from telecommunications to computer networks, where efficient data routing is paramount. By understanding the role of demultiplexers, we gain insight into the intricate workings of modern electronic systems and the sophisticated methods used to manage data flow. A demultiplexer, often shortened to demux, is essentially an electronic switch. It has one data input line, multiple data output lines, and a set of selection lines. The selection lines act as the control mechanism, determining which output line receives the input data. The input of a demultiplexer is like a single pipeline carrying data. The outputs are like multiple pipes branching out, each leading to a different destination. When data arrives at the input, the demultiplexer selects one of the output pipes, based on the instructions from the selection lines, and sends the data through that specific pipe. The selection lines are crucial to the operation of a demultiplexer. These lines carry binary values, 0 or 1, which collectively determine which output line is activated. If a demultiplexer has n selection lines, it can control 2 to the power of n output lines. For example, a demultiplexer with 2 selection lines can control 4 output lines. 2 squared equals 4. Section 5. Demultiplexers in action. Real-world examples. Demultiplexers are found in a wide range of electronic devices. In communication systems, they are used to route data packets to specific recipients on a network. In memory systems, demultiplexers help select the correct memory location to access. They are also used in digital displays, where they activate the appropriate segments of a 7-segment display to show numbers and letters. Section 6. The significance of demultiplexers in digital systems. Demultiplexers are essential building blocks in digital circuits and systems. They play a vital role in data distribution, signal routing, and control logic. Without demultiplexers, it would be incredibly complex to direct data flow in a controlled and efficient manner. Their ability to selectively route data makes them crucial for various applications, from communication networks to computer systems. Section 7. Analogies for understanding. To further grasp the concept of a demultiplexer, consider these analogies. Analogies are powerful tools that help us bridge the gap between complex ideas and our everyday experiences. They allow us to visualize and understand abstract concepts by relating them to familiar scenarios. Let's dive into a couple of analogies that will make the idea of a demultiplexer crystal clear. Imagine a bustling mailroom, where a diligent worker is sorting letters into different pigeonholes based on their addresses. Each letter represents a piece of data that needs to be delivered to a specific destination. The mailroom worker carefully reads the address on each letter and places it into the corresponding pigeonhole. This process ensures that every letter reaches its intended recipient without any confusion. In this analogy, the mailroom worker acts as the demultiplexer. The letters are the data that needs to be distributed, and the pigeonholes represent the output lines. Just as the worker sorts the letters based on their addresses, a demultiplexer directs data to the appropriate output lines based on control signals. This ensures that each piece of data reaches its correct destination, much like how each letter finds its way to the right pigeonhole. Now let's consider another analogy. Think of a water distribution system with a network of pipelines and valves. Water flows through the main pipeline and is directed to various smaller pipelines that lead to different parts of a city. The valves control the flow of water, ensuring that it reaches the right locations. By opening and closing the valves, the system can manage the distribution of water efficiently. In this scenario, the valves act as the demultiplexer. The water represents the data, and the pipelines are the output lines. Just as the valves control the flow of water to different pipelines, a demultiplexer directs data to the appropriate output lines based on control signals. This analogy helps us understand how a demultiplexer functions in a more tangible way. By visualizing these everyday scenarios, we can better grasp the role and importance of a demultiplexer in data distribution. Section 8. Demultiplexers versus decoders, spotting the difference. Demultiplexers are often confused with decoders, but there's a key difference. While both have selection lines and multiple outputs, a decoder activates only one output line at a time, effectively converting a binary code into a specific output. A demultiplexer, on the other hand, routes data to the selected output, allowing for the transmission of information. Section 9. Conclusion. Mastering the basics. Understanding demultiplexers is fundamental to grasping the intricacies of digital electronics. These devices are essential in breaking down complex data streams into simpler, manageable parts. By doing so, they enable efficient data processing and distribution, which is critical in various applications ranging from telecommunications to computing. These versatile components play a crucial role in data distribution, signal routing, and control logic. They ensure that data is accurately directed to the correct pathways, minimizing errors and enhancing system reliability. In essence, demultiplexers act as traffic controllers in the digital world, guiding data to its intended destination, making them indispensable in countless electronic devices we use daily. From the smartphones in our pockets to the computers on our desks, demultiplexers are at the heart of these technologies. They enable seamless communication between different components, ensuring that our devices function smoothly and efficiently. By mastering the basic principles of demultiplexers, you gain a foundational understanding that is crucial for anyone looking to delve deeper into the field of digital electronics. This knowledge not only helps in academic pursuits, but also in practical applications, where troubleshooting and optimizing electronic systems becomes significantly easier. You unlock a deeper understanding of how digital circuits function. This deeper insight allows you to appreciate the complexity and elegance of modern electronic systems. It also equips you with the skills needed to innovate and improve existing technologies, pushing the boundaries of what is possible in the digital realm, and pave the way for exploring more complex electronic systems. As you advance in your studies or career, this foundational knowledge will serve as a stepping stone, enabling you to tackle more sophisticated challenges and contribute to the development of cutting-edge technologies. Mastering the basics is not just about understanding current systems, but also about preparing for the innovations of the future.